Welcome back. In this video I'll be discussing structures. So let's begin by opening Visual Studio and creating a blank project and having our main CBP. So just so you get used to typing the code and having the code under your fingers, let's just start with a blank file and start typing. So we'll do some includes. We'll do include IO stream, and then I'll include there we go. String. And then we'll have our main. And we'll give it a return of 0. So that's our basic boilerplate code, our template that we use some variant of every single time for our main program. So let's start with typing some code here of a structure. So let me type the code out first, and then I'll explain it. So the first structure I'm going to make is a car structure. STR. I have to spell it correctly. And then we'll give it some features, some properties. We'll say the car has a miles per gallon. It has number of wheels. Most of the time I imagine it would be 4, but I guess if you had a truck of some sort, you could have additional wheels. And this may seem strange when I say number of wheels in a car, and once we get later in the course you'll understand, well, when we get into object-oriented programs we can do something called inheritance and have some generic car which are either a car or a truck or something else. So don't worry about that just yet, but we'll get to that later in the course. So a car probably has a maximum speed of some sort. We'll say that's a float. And really, miles per gallon, I suppose, could be a float or a double as well. So let's do that. In the real world, I think most people don't speak of their miles per gallon in the car. They usually round down or up to the nearest decimal place. But so number of wheels is definitely going to be a whole number. So max speed. What other features could we have? Let's say a string, a make, and a model. Okay. And let's also do a string of color. Okay. So what is a structure? So far in our review, we've been working with individual floats or ints or doubles or strings inside of our program. So if we wanted to have a program that used a car, up to this point we would have probably just put all these individual things right inside of our main, and that would have been a car. So a structure is taking all these things and inside one logical unit putting them all together and making them available. So then later if I wanted to use a car or do something with a car, I would say struct car, and then I would say what kind of car it is. So let's say let's say my car. That's a better idea because we already have a make and model, so we can put what kind of car it is in there. So then we start, and this is just kind of syntax. So we say my car, and then let's say we want to make the color equals blue. And then so on and so forth, and you would go in and fill in all the different properties inside of that structure. Okay, so I hope that makes sense so far. But what do you do with it? Right now we just have a structure that we're using, and we're defining some stuff, but right now it's not doing anything. So in this course, as I mentioned, this is the data structures course. So car is actually a data structure. You're taking a bunch of unstructured data and giving it structure. So that may seem a little funny. I'm kind of using the definition of the word within itself, but you in programming, typically you have, and in just in all of computing, you have data structures and you have algorithms. So in this case, this is our data structure, and instead of having just a different bunch of loose pieces of floats and ints just sitting in your main program, not really being one logical unit, when you make a data structure, you force it all into one logical unit. So I mentioned that there are data structures and then there are algorithms. One of the benefits from making a struct, and I'm not sure how much you worked with structures in COP 2000, and typically when I first encountered these, I had a little bit of a hard time understanding why you would even need it or why you would use it. So let me give you a perfect example of how you'd use a structure. So let's make a function, and this is a little oversimplifying right now, but let's make a function called start car. And what this function does is, for right now, it'll be a void, and once we get into pointers later, we'll explain why this actually doesn't work 100% correctly, but this is just a simplification. So what we want to do is make a function called start car that doesn't return anything, and to that function we'll pass our struct car, and we'll just say, you can call it car, but let's so you know which one's the struct and which one's the actual name of the local variable. Let's call it car instance. Okay, so we've got a structure of a car, and that's our structure up here, and then we're saying that the name that we're going to use within our function is actually the car instance. What you'll sometimes see people do is do struct car, which will work. It makes things a little confusing, because especially when you are writing a program and you want to use somebody's struct, it can get a little confusing. Are you talking about the struct car, or are you talking about the local instance car? So let's just call this car instance. Okay, and let's add a boolean here. And then so when you go to start the car, what we do is we say car instance dot is started equals true. Okay, and to use that, we would call start car, and then to that function we'd pass my car. Now, as I said, once we get into pointers, and C++ has something called references that makes pointers a little bit easier to use, or a little bit more manageable. I'm not sure how many of you have actually had experience with that, so I may leave references out, but we'll definitely cover pointers in this course. And so to technically make this work like we'd want to, we need to use a pointer, but right now we're just passing a copy of car, which is fine. I just want you to get the intuition and the general overview of what's happening, and this is sort of a review for those who haven't had it in a while. If we didn't have that, it would be a little bit tougher, because if we wanted to start our car, if we're working with a car, how do we start it? Well, we'd have to create a variable boolean is started, and it would probably have to be an instance, so we'd have to say my car is started, and it would get a little tougher, and especially as a program grows and it gets really big and you've got a program that's hundreds of lines of code, and even sometimes thousands of lines of code. Definitely not in this course, it won't reach thousands of lines of code, but if anybody goes on to a program to be a programmer, it's pretty typical that once you start a program, you'll be working on it for years and add 100 lines of code here, 100 lines of code there, and over the years it'll really add up. So, but that's what a structure is. Once we go into pointers, I'll revisit structures and explain exactly why this doesn't work as we're intending. It's actually starting a copy of the car and not the actual original car that we have. So, but for now, that's Structs in a nutshell, and stay tuned for some more videos going deeper into structures and functions and pointers.